Hello and welcome back to Numpy YouTube channel video. In today's video, we're going to be taking a look at data analysis with Python. So basically, I want to walk through this Freecodecamp course with you, tell you some of the things I've learned, how it can be very useful in the modern day, and basically all the tools I've used in order to help me complete this course. So there are 28 videos, and there's a short Numpy course, but I decided not to do it because they cover Numpy quite extensively here. And then there are 5 projects to complete, so we're going to walk through all of these projects and kind of understand how we can use data in the modern world to just have a lot of power and influence. We know in social media apps and a bunch of other services like Google use data analysis in order to gain an insight onto what, say, a user may want to purchase or a user may want to see in terms of social media posts. And we can see how data analysis can be very powerful and also very quick. So let's take a look. Make sure to like, subscribe, and comment your favorite thing about the video or how it can improve my code. Before we get into the explanation of NumPy, I want to give a quick explanation on what data analysis is. Data analysis is the process of cleaning, transforming, and kind of reshaping data to see if we can make any observations. These observations are usually made using graphical elements, such as matplotlib, seaborn, and other things we'll see in the Replit projects. So, that in mind, let's continue on to NumPy. So NumPy was the first kind of idea taught. So we could see after learning about Jupyter Notebooks, we had an introduction to NumPy. So I'm going to cover that really quickly. So NumPy is an numeric computing library and basically does a lot of, it improves a lot of the speed with results to kind of like lists and making and using NumPy elements allows the programs to run a lot faster. Initializing NumPy arrays, we just have basic NumPy arrays, which when printed, so if we initialize B here, you can see when printed, it just prints an array of those elements. Then let's scroll down into the summary statistics. So here we can see, okay, if we have an array named A, NumPy array 1, 2, 3, 4, the sum of that is 10. The mean is 2.5, and so on and so forth, even variance, and there are various other functions that we can use as well. So now if we have a two-dimensional NumPy array, which is like a matrix, then we can just do the same summary statistics, and we can even do it along axes. So an axis of 0 means that I believe it does rows. No, it does columns. So axis of 0 returns a NumPy array of all the sums of each column. So for example, 12 is the sum of 1, 4, and 7. 15 is the sum of 2, 5, and 8, and so on and so forth. I don't want to take too long on NumPy because it's quite simple. But let's take a look at speed. All right, so now here we can see I've defined I've defined one NumPy array, which is a nested, which is it's a 10,000 by 10,000 matrix, which took a while to actually make, but then the summing took 0.13 seconds, whereas in a normal Python array, initialized the same way, the summing took 17.8 seconds, this ON squared solution. So we could see just the quickness of NumPy, 0.1 seconds to sum a 10,000 by 10,000 array. And that's basically it for NumPy. That's the general idea. Next, we're going to take a look at Pandas data frames. Here in a data frame is basically a table of data, as we can see in the analysis of G7 countries. So we can see here that we have countries and we have their population, GDP, surface area, human development index, and continent all stored in a table titled G7 stats. So this data was manually imported, but we'll see in the projects how we can import data given given a CSV file, comma separated values file. So a data frame or a table is the main idea that we used to kind of read data in all the projects. So it says creating data frames manually can be tedious. So 99% of the time, you're pulling data frame from a database, a CSV file, like I said, or or a website. Here they manually created this data frame, and we can see here that we can have various columns describing the names of the information. And if we scroll down, one of the main ideas used was conditional selection in the projects. So basically this is selecting kind of based off of some condition, right? So we have a data frame, which was the data frame that we initialized earlier. And it is, it has the countries, it has their population, GDP, surface area, and so on and so forth. So basically, we have this data frame, which is printed, shown here. Now this statement says that we want to select the data frame, the elements from the data frame where the population is greater than 70. So these populations are greater than 70. So it's going to say Canada is false, France is false, Germany is true, has 80 million people, and so on and so forth. So now df.locate or lock is one of the main ideas also used in the projects. So basically we're returning a data frame where we get the elements where the population is greater than 70. So we can see how we can use these ideas and other various conditionals in order to select data that we want and data that we want to analyze. Describe is a very important thing that will be used, and we can find all the various summary statistics like the mean, the population mean, the average GDP, average surface area, average HDI, and average GDP per capita. Then we can kind of get the idea there. So now I want to give another kind of time example. So I imported a file called COVID transform data.csv. So this is a Excel spreadsheet of comma separated values, and it gives a bunch of kind of analysis on COVID-19. I believe it was over 1 year. And so we have the country code, we have the country name, date, and so on and so forth in the columns. And then we have 50,000 elements. So you can see here it ends in Zimbabwe with about the 50,000th element. So we can see here that, so I'm going to kind of set a time and I'm going to read the CSV file of COVID transform data. And we'll see that that takes 7/100ths of a second to read and put the data into the data frame into a table, which can be seen here. So making this whole table of 50,000 elements only took 7/100ths of a second, which is extremely quick. Finally, let's take a look at all the projects completed for this course. Project number 1 was a mean variance standard deviation calculator. And basically the main idea that we wanted to do was use those summary statistics in order to make observations. We wanted to calculate the mean variance and standard deviation of this list here. We made a Numpy array using the elements, so the of length 9. So we only kind of modified a 9 length array. And then we made a dictionary, which is what we wanted to return. So we can see here that the expected value is a dictionary here. And we want the means. We want the mean on all the x's. So this would be the columns. You can see all the highlighted things are axis 0, which should be all the columns. So we want to get the means of all the columns. We want to get the means of all the rows. And then we want to get the means of the total Numpy array. So the second project was titled Demographic Data Analyzer. And the idea was to make a data frame by using read.csv, adult data CSV, which is the file here, which has a bunch of information on various people, such as your age, work class, I forget what this means, education, marital status, occupation, relationship, race and sex, and so on and so forth. So we had to answer various questions. How many of each race are represented in the dataset? So we had to use a lot of kind of conditional checking. So I made a race count. I made a series of a Pandas series where I had to iterate for each race that I found. So this is where this unique attribute is used. So we wanted to say find all the unique races, put them in a list, and then make a series where we find all the elements in the data frame where the race is equal to the current race in iteration, right? Because using this kind of a vectorized operation. And then what is the average age of men? What is the percentage of people who have a bachelor's degree? And then a bunch of other questions. All right, and now we're going to be taking a look at medical data visualizer. So here we're going to start making categorical plots and heat map plots using Seaborn. So we import the data, we make a data frame of the medical examination.csv file. So we can see here that we have ID, age, sex, weight, and so on and so forth. Then we had to do some cleaning. First, we need to add an overweight column. So this was just some kind of math, quick math, and using a lambda function to make a new column. Or to make it so that if the value, this is the BMI calculation, if the BMI is greater than 25, just set the value equal to 1 as meaning true. Otherwise, just say 0. And then we need to normalize data. So this is part of the data analysis idea of cleaning data by making 0 always good and 1 always bad. So if the value of cholesterol or glucose is 1, make the value 0. So 1 in the project was described as a normal level. So make the value 0. So 0 is always good, right? And vice versa if the value is more than 1, which is always bad, and it was described as bad in the description of the project, then make the value 1. So we can see here how this quick kind of idea can be used in larger scale kind of ideas, right? So let's say if you're on if you're on a social media website, let's say Twitter, and you saw a tweet about something along the lines of basketball, and you spent a lot of time looking at that tweet and reading the comments. So we could just make a simple statement and say, okay, the people who say, let's say the people who spend a lot of time on that basketball tweet, we're going to use some type of metric to analyze that, and we're going to say, okay, recommend them more basketball ideas. So we can say apply kind of a basketball idea to them, or apply a basketball characteristic that they like basketball more, for example. So very quickly we can see these kind of large-scale ramifications, and this does not take very long to execute. So it'll be a very quick execution, which that means that we can analyze large sets of data and large sets of people, make a very quick informed decision about them using Pandas, for example. Now we want to draw the categorical plot. So draw cat plot as a function, and we make a categorical data frame using melt. And we can see here that in the cat plot image, it's a little bit low res, but generally speaking, on the right side is people who did not have cardiovascular problems, I believe was the idea. Cardio didn't mean like actually like running or anything like that. That was the active variable. Cardio, I believe, meant like cardiovascular problems. So on the left side are people that did not have cardiovascular problems. And we can see here that active people, there's a lot of active people. I guess the values. So the orange means that they did partake in the task. 0 means that they didn't, generally speaking. So there are a lot of active people. There were not a lot of alcoholics. There were not a lot of people with high cholesterol, a large blue line, and so on and so forth. We can see here that the overweight was kind of equal. So that means that, regardless of whether they were overweight or not, didn't really play a factor on cardiovascular, so far as we can tell, because we can see here on this side, right, the overweight people who are overweight, so that's the orange line here, had a pretty high chance compared to people who were not overweight to have cardiovascular problems. And so, for example, smoking, people who didn't have cardiovascular problems didn't smoke. People who did have cardiovascular problems also didn't smoke. It's kind of a strange, there might not be a correlation there, because we can see in both graphs that the smoke variable is usually 0. People usually didn't smoke. Either way, I guess, so there wasn't much of a correlation with that. Or the amount of people who didn't smoke and didn't have cardiovascular was the same as the people who didn't smoke but did have cardiovascular problems. That's a general idea of cat plot, of the categorical plot. And then, you can see, then we would draw a heat map. That heat map can be seen here. And the idea is that, so the first idea is we want to clean the data. So we want to get rid of the lower 2.5% of the data and the upper 2.5% of the data. So I'm not going to explain this too much, but that's generally what this does. Then we calculate a correlation matrix, create a mask, and then set up the figure. So here we have a figure, and basically this shows the kind of correlation between various, various problems. That makes sense. So if I were to download that, you could see here that, for example, weight had a good correlation with being overweight. So the more weight you were, the more chance you had of being overweight, 0.7. Let's take active and sex, right? So the active and sex had a value of 0, which means there is no correlation, right? All the values of 0 means that there's no correlation. And that is the general idea of this project, to kind of map medical data and to make conclusions like so. Page view time series visualizer. This is the 4th out of 5 projects. And this project, we made 3 graphs. So we made a line plot, made a box plot, and a bar plot. So let's import the data first, right? We read the CSV of the Freecodecamp forum page views. So we can see we have a date and a value, and we can see that the page views are slowly increasing as time goes on. You can see here, for example, that for November 10th, 2016, there was 117,000 page views. That's a general idea, and it goes on for about 1,300 lines. So 1,300 days we are evaluating. So first of all, this is cleaning data and reformatting it. So we want to make sure that the date is a datetime object, so we use Pandas to do that. And then we get rid of the bottom 2.5% and the top 2.5%. That's what happens there. And on the line plot, after doing all this, the line plot looks like so. So it's a little bit grainy, but I think you can see the idea that over a couple years, so from 2016 to about the end of 2019, the Freecodecamp forum page views is generally increasing. You see that? You can see that line. So now, let's take a look at the bar plot. So the bar plot looks like so. So for each year, we have the corresponding months plotted out. So for 2017, for example, we have the first bar January, second bar February, and so on and so forth. We can see that the views are generally increasing this way as well. So we can see in 2019, for each month, the number of views is greater than 2016. We can see this positive correlation between time and the number of views. We're not really going to talk about most of this code. A lot of this code is quite difficult. Kind of the idea of grouping all of these bars by year was pretty difficult. And I had to use a Stack Overflow website that talked about matplotlib kind of grouping in order to figure that out. So we can make that general correlation, or that general idea, right, from both of these plots. We can see that, okay, the correlation is, increasing, And then we can see from the bar plot too that the correlation is also increasing as well. So finally, we make a box plot. So here's the general code for that. That box plot looks like so. This is a little bit grainy, a little bit hard to read, so let's download that. Let's take a look. We can see here that we have a year-wise box plot and a month-wise box plot. So we can also see here that as years go by, there's a general increase in page views. But for month, we don't really see a correlation, but we kind of expect that. So since we're making box and whisker plots, when we're talking about month, there really isn't much of a variation between months. We can see that October, okay, has a high maximum, or I guess a high, that's not really a maximum. Actually, I guess it is a maximum, yeah, but it's just not an outlier. And then here we have various outliers we can see. But generally speaking, we wouldn't really expect the average of a certain month to be anything greater. Like if, for example, the December one was up here, like this whole box was shifted up here, then we would say, okay, in December, there's generally more views on the Freecodecamp forum. Like for example, if instead of being the forum website, it was a Halloween website, then we would expect the October page views to be a lot higher, generally speaking. Right? But that's not the idea here because it's just a forum website and it gets used all the time. So that's the general idea of page view time series visualizer, not simulator or anything like that. So let's get into the final project. All right, finishing strong sea-level predictor. This is a project working with scatter plots and making regression lines. So let's take a look. So we want to draw the plot. So this was the only function, the only task we had to do for this project. So we wanted to read the data from the file. This data captures year, it captures sea level, and those are the two values that we want to use. So for example, in 1880, the adjusted sea level is 0. So this is just a kind of we can see the impact of the industrial revolution, as we'll see as the years goes on, and we'll see here. So we can see here in the scatter plot that the sea level in inches is generally rising pretty quickly, I might add. It's got a strong correlation, although these years are pretty far out. I guess it's taking like 200 years to go from 0 to like 10, but still. So first of all, we want to make the scatter plot. So that's very simple, using axes and figure a dot add subplot. And then we want to make a linear regression line using Scipy. I think it means like statistics python.stats. We import the linear regression, and then we make two linear regression lines. So the first one we can see in red is from the start of the data all the way to the year 2050. And the second one is the year from the year 2000, making a regression line from values that have the year 2000 and above. And we can see that from the year 2000, this blue line has a much steeper rise than the general trend since the Industrial Revolution. So we can see that, oh no, we're making some big mistakes and the sea level is rising quite quickly. So we can see the difference from maybe about 10 inches here to about 15 here, just from the growth from 2000. So that's the general idea, and we can see that from the year 2000 that this, our sea level has been rising at unprecedented rates. This rate was kind of the same for hundreds of years, but then since 2000, it's really taken off, which is something to be alarmed about. So using data analysis, we can make these kind of conclusions, and we can say that, oh no, the sea level is going to, I don't know, sweep up California or something like that in the next 50 years. So, some idea like this. So that is the general idea of data analysis, right? So we take huge portions of data like this huge CSV file, or this CSV file isn't that big, only 135 lines. But if you give this file to, just a human at a desk, just this paper, he's not going to know what to do. He's going to say, I got to really plot all this by hand. That's not the, that would be pretty bad. Or that'd be pretty tedious when we can just use um, matplotlib and we can give this very nice graph that kind of we can see that there's huge discrepancy between the rate of change of the sea level in inches from the year 2000 as compared to from the start of the data analysis, which is the year 1880. That is the first year. So generally speaking, we can kind of understand how these basic, sea level predictor and medical data visualizer and all these other projects can have a large impact on how society is run. So we can see, we can make observations from medical data and we can say, okay, we need to prescribe this drug to this, certain set of people because it meets this data kind of analytic conclusion. Where we need to say that, oh, if the Freecodecamp forum isn't getting enough views, or for example, in the year January, the views are stagnating, or if the views are lower than the rest of the months, then why is that happening, right? We can use this data and we can identify what needs to be changed and what needs to be modified in order to be more productive, make more profit, and all these various things, right? So we know, let's make a general conclusion, right? That social media apps want to keep you on the app for longer. So they're going to use their data analysts that they hire, and they're going to say, find out, use data, right? Make these regression plots, make these bar charts, these pie plots, the scatter plots, make all these plots and realize or kind of make conclusions as to, say, if this person watches a basketball video for this amount of time, or watches this many baseball videos, let's recommend them this amount of basketball, this amount of baseball to keep them on the platform longer, right? That's a general idea. And we can see how powerful that can be in kind of controlling what people watch, right? So overall, I hope I left you with a good kind of ending remark, and I hope you really enjoyed this video. And I know I did. It was super fun to make and explain this data analysis course. I've now gotten a certificate for it, and I've learned a crap ton along the way. So I hope you enjoyed my explanation here today. Thank you very much.